my name is Pamela. Welcome to my channel. Today I'm gonna talk about communication between industrial instruments is based on pneumatic, electronic, and digital analog signals, the latter being capable of handling large amounts of data and storing them in historical units, as well as being the most accurate. Digital signals are transmitted through communication cables called buses, which sequentially transmit electrical signals that represent information encoded according to a protocol. Inter-instrument communications were initiated with the serial port, through which you can configure, view diagnostics, trends, and more. The most used interfaces are RS-232. This is an unbalanced electrical configuration for transmitting digital signals on a simple baseband. It has 3 conductors, one for transmission, one for reception, and one for common current return for both types of data. The cable acts as an antenna, being able to send and receive signals from nearby devices, including unwanted ones. It transmits the data with negative logic. This is, the zeros are positive voltage and the ones are a negative one. The most used voltage is plus minus 12 volts direct current, and it can transmit in a radius of up to 15 meters at maximum 20 kV, being the common one of 9,600 volt in the industry. RS-422 appears in 1978 to cover the need for greater speed and transmission distance, but it was not as widely used because most serial communications are in clean environments, such as offices, where the computers are also close to each other. You can transmit at 1,200 meters, but if you want to transmit at the maximum speed of 10 megabaud, the distance is limited to 60 meters. RS-485, introduced in 1993, it is designed for multi-point communications and applied when there are less than 32 stations and the data quantity requirements per second are moderate and of good quality, being the maximum communication distance of 1,200 meters with a speed of 10 megabits per second. Hybrid protocols use the 4 to 20 mA DC analog communication standard in addition to incorporating a digital communication protocol, and these are DE. This protocol consists of a current modulation, state 1 being a current of 20 mA and state 0 being a current of 4 mA. It supports 4 to 20 mA DC analog signal, but not simultaneously. Uses a private protocol. In tensor, brain. In this, the absence of pulses means a state of 1, while a state of 0 means 2 up and 2 down pulses with amplitude of 2 mA DC. This signal is modulated on the 4 to 20 mA DC signal, which is not affected because the resulting signal is known, Foxcom, FSK, which is based on frequency modulation, its maximum transmission distance being 1.6 kilometers. And finally, we have the HART protocol, of which I already have a video on my channel where I explain the basics. To understand what I will explain about this protocol, I will tell you about the OSI model that was proposed by the ISO in 1980. This model is made of 7 levels. The first is the physical level, and there is defined the physical medium through which the communication will travel, the material and the electrical characteristics and the functional characteristics of the interface. It is also where the bit stream is transmitted. The transmitted electrical signals are handled and the connection is guaranteed. The second level, which is the data link level, is responsible for physical addressing, access to the medium, error detection, order distribution of frames, and flow control. The third level is the network level and is responsible for identifying the existing routing between one or more networks. The fourth level is the transport level and is responsible for transporting the data from the source machine to the destination one. The fifth level is the session level and is responsible for maintaining and controlling the link established between two computers. The sixth is the representation and is responsible for representing the information in a way that is recognizable to the different devices. The last level is the application level and is responsible for having access to other levels and defines protocols that applications use to exchange data. In this case, the HART protocol implements levels 1, 2, and 7. Level 1 because it physically connects the devices and modulates the superimposed signals. Level 2 because it forms and checks the frame of the messages according to what the protocol indicates. And 7 level because it uses commands that are sent to the transmitter to obtain information. The digital integration of the instruments with control systems is implemented with the Fieldbuses. The first open Fieldbus was Modbus, that only had level 1 and 2. The most important open communication protocols are HART, World FIB, ISP, Bitbus, Interbus S, PNet, Echelon, and CAN. Of these, those that use Fieldbus protocol are World FIP and Profibus PA. The existing Fieldbuses are Longworks, Interbus, ASI, DeviceNet, CAN, PNet, World FIP, Profibus, and Foundation Fieldbus. But I will explain this to you more fully in the second part of this video, so wait for it. This system is widely used in remote access, difficult or dangerous applications, and it is made up of a radio base that can accept up to 50 digital communication units via Modbus, or an analog electronic signal of 4 to 20 mA DC. Its advantages are saving cable, faster startup of the installation, transmission distance of up to 600 meters without obstacles, accuracy of ±0.1%, long battery life, which makes it reliable. It has self-testing software for the devices. It is free of interference thanks to the transmission frequencies of 902 to 928 MHz, which is the digital protocol FHSS. Frequency hopping spread spectrum that modulates the data signal with a contributor hopping from frequency to frequency in a wideband. It has about 30 megawatts of transmission power and a speed of 4.8 or 19.2 or 7.8 kilobits per second. Each data block is verified and confirmed by the radio base. High frequency or normal sounds can also be transmitted to detect malfunctions. For example, sounds generated by relief valves, purges, pumps, and compressors. And well, this will be all for today's video. Don't forget to give me a like and subscribe. I upload videos every Friday and on Wednesday in Spanish. Adiós! Acts as an common one of